So on the back side here, we want you to not find your average acceleration in this diagonal direction. We want to know what the actual vertical acceleration is going to be. We're going to have you guys break this thing up into components. Okay, now you know how to do it, sine, cosine, tangent stuff. It's not going to be exactly the way this thing's drawn, though. All right, it's not just finding this little piece right here, and there's our angle and being done with it. We're going to draw it a slightly different way. Okay, so here's how I want you to draw it. You got your average acceleration in this direction, so it's going to look like this. And there's your little average acceleration component. That's what you guys have already calculated. All right? We want the vertical acceleration when our little right angle's right here. Okay, so it's going to kind of look like this as we piece it together. Vertical acceleration. There's our little right triangle. And we're looking for this A vertical direction here. AV we'll call him. You know the acceleration it went in this direction, or you should have already calculated it. Once for one angle and once for the other angle. I want to know what the vertical acceleration is going to be instead. Okay. Now, this angle right here that you guys measured to be 1 degree, 2 degrees, 5 degrees, whatever it was that you've measured yesterday, is actually this angle right here now. The angle moves over there. Okay. The way this all points together. So let's see what we're going to be actually using to find this guy. We know him. We know the angle. We're looking for him. Okay, so for that angle, this is my what side? Opposite. There's the right angle, making this side the hypotenuse. And then over here must be the adjacent, which you don't know, nor do I care to find, so I don't even care about him. So which function are we going to be using? The sine, cosine, or the tangent for our little scenario? Sine. Okay, we're going to want to use sine. So you're going to basically do the sine of your angle. Let's say the angle was 1.5 degrees. Okay, that's just going to be my angle. Okay? Equals opposite. Oh, that's the acceleration I've already calculated. I got that on the front side down here, right? Average acceleration. Let's say my average acceleration was, I don't know, 0.04 meters per second squared. I don't know. I'll just make something up. Divided by the hypotenuse. The hypotenuse is, the vertical acceleration. Oh, that's what we're looking for. So, acceleration in the vertical direction. It looks something like that, wouldn't it? All we're doing, our acceleration, then our marble. Our marble's rolling and rolling and rolling and rolling and rolling and rolling. We already calculated that average acceleration for our marble at one angle and that at a completely different angle when the book was closed, right? So we have two different calculations. One of the angles, maybe the smaller angle is 1.5. I don't know, maybe it's 2.4 for you, maybe it's 1.04. Each of you probably has a different angle because you all had the book open up to a different page. Okay? And then your average acceleration, that's from the front side. That's your opposite. And then your vertical down at the bottom. Right? Should you be able to solve something like that? Hopefully. Again, you can put it over a 1, cross multiply, and do whatever you want. But we're looking for him. Okay? And you're going to do it for not only the one angle, but for the other angle as well, whatever it might be. And for the other acceleration, whatever it might be. And find that other acceleration in the vertical direction. So we're going to have two different vertical accelerations. Okay? So I'll give you a few minutes, let you crunch those out, and then let you get with your groups for a few minutes and just kind of talk about the rest of the answers. Okay? So everybody do their calculation on their own.